Hi, my name is Joy, and today I'm presenting our work on naturally supervised 3D visual grounding with language-regularized concept learners. We study the task of 3D visual grounding, which takes an input query, for example, select the printer next to the copier, and outputs the object that the expression refers to. Here, the object in green. In the canonical directly supervised setting, this referring expression comprehension task is supervised by the 3D scene and question-answer pairs, as well as the ground truth 3D bounding boxes during training and inference, and object-level classification labels during training. We instead study the naturally supervised setting, where models are given only the 3D scene and question-answer pairs. So how do we learn in this indirectly supervised setting? Our proposal is to leverage structured intermediate representations from neuro-symbolic models and inject language-based constraints through regularization as learning signal. The constraints capture the taxonomy of words in relation to one another. For example, that the chair near the table indicates that the table is near the chair. Or that the painting behind a vase indicates that the vase is not behind the painting. Or that wardrobe and dresser are visually similar and synonymous. Our framework, LARC, first extracts explicit constraints from large language models to be used on structured and interpretable representations from neuro-symbolic models. These representations are entity-centric and indexable by concept and object. For example, each value in FREL represents whether object I and j satisfy a given relational concept. Then programs operating on concepts are parsed from the input query, and LARC executes the programs with the learned representations. Finally, LARC regularizes the structured representations to encode constraints. For example, that the relational matrix for the concept close should be symmetric. We see that LARC's learned representations more faithfully follow language properties compared to the base neuro-symbolic method, NS3D. For example, it is more symmetric for the concept close. In experiments, we show that these learned representations significantly enable LARC to outperform prior work in generalization to a new dataset. We train all models on the referred 3D dataset and test on the scan-referred dataset. We see that our method's robust representations enable successful transfer. LARC also enables strong zero-shot generalization to unseen concepts by leveraging language rules to compose learned concepts in execution. We train on referring expressions without ternary relations, for example, center of, and antonym relations, for example, not left. Then, we test on referring expressions with ternary and antonym relations. LARC significantly outperforms all prior works on this setting. Importantly, we see that LARC is data efficient in low data regimes, as it uses general and explicit language constraints as learning signal instead of directly labeled data. To summarize, we introduced the Language-Regularized Concept Learner, LARC, which extracts explicit language-based constraints from large language models and injects them into structured models for vision as regularization. We show that such language regularization serves as an effective signal for learning in naturally supervised settings. Thanks, and check out our project page and code for more details.